50% is right here in the interval. I don't care if it's further to that side than it is to this side. The important thing is it's in the interval. It's in the interval. That's the important thing. That means that at 99% confidence, I have to accept the reality that I might actually get more heads than 50%, or I might get less heads than 50%, or I might get exactly 50%. In other words, this is an inconclusive interval if I want to compare it to 50%, because it goes over, below, and right at 50%. Is it inconclusive if I want to compare it to 70%? Hell no! I can tell it's less than 70%. Is it inconclusive if I'm comparing it to 60%? Is it inconclusive when comparing it to 60%? I didn't put 60 on, I'll put 60 on here for you. There's 0.6. Is it inconclusive with 60? No, because it's all below 60, yes? Go ahead, Nick, go with your thought. What were you going to say?
I just said hell no.
Oh, you said hell no. Hell no. Exactly. Is it inconclusive at 55%? Is it inconclusive at 54.5%? But it's inconclusive at 50%. And the reason is that interval doesn't tell us, is it below, is it above, is it right there? It could be anywhere. That's what the interval shows us. It shows us the range of possibilities based on our sample. The range of possibilities for the percentage of heads. It might be as low as 40 or as high as 54, but we can't tell the difference when compared to 50%. We want it to be lower because we got 47% right here, yes? But with a plus or minus 7%, that gobbles up any difference. Because 47, as Alan correctly said, is only 3% away from 50. Well, if you go 7%, which is what Carly's 97% or 99% confidence necessitates, that pushes us over that 50%. Nick, go with that question.
I was just going to say that since Carly's 99% positive, that's going to be between 40 and
54.
We could say that that basically is the conclusion.
That's what you have to say based on your sample data. So now what I want to do is come back to what does it mean to be 99% confident? Now you guys already told me. You guys already told me, yes? You guys already told me that if I did this experiment again, I would or would not get the same results. I would not. But what would I most likely get?
Something close.
Something close to those results, yes? Now are you seeing that up here in this collective data spreadsheet? Oh, there actually is a 340 up there? Hot damn, where is it?
S11.
Spring 11, 340, and they got 134, which is similar to your guys. No, actually, you guys got 160, they got 134. That's actually pretty far away. Let's go find them on the screen, actually. Let's go find them on the screen. Fall 11, 134, 330, fall 11. Yep, there they are. They had a different conclusion than you, didn't they, when they ran their study? Did they say there was a measurable difference between flipping and spinning a coin in fall, or whatever that was, fall 2011? Look at their interval. You don't have to know what the numbers are yet. We're going to focus more on that later. Fall 2011, there's 50%. Did fall 2011 say there's a difference between flipping and spinning a coin? Yeah. Yes. How about winter 2011?
Yeah.
Yes. How about fall 2010? No. See how close they are? They wanted to. They're like, but it's so close.
I
Doesn't
wonder
count.
if it's like in the rotation of the Earth or something, because I mean, you can tell that.
Don't read too much into that pattern.
Okay.
Don't read too much into that pattern. It's also, don't read too much into the pattern, nor the fact that as I got down lower, I started controlling the experiment more carefully. Yeah, and plus some of these were done in very different areas on campus. One was on the Oregon coast and all kinds of things. So don't read too much in any kind of underlying pattern because there should not be one. Please, Carly.
Quick question. So for your confidence percentage, if it's smaller, like is it the smaller it gets, is it the less your margin of error gets?
Did everybody hear what Carly just said? She said, if you make your confidence less, is your margin of error going to get less? Is the answer to that yes? It has to be. Why? Suppose we go to 95% confidence, Carly. So suppose we go to 95% confidence. You know what? To hell with this. Let's go to the TIs. Let's show you how to do a shortcut on the TIs. The answer is yes. Mathematically, and what I was going to point out is, this number will shrink as your confidence goes down.
Okay.
So this will become 2, which clearly will make this whole number less. Remember, this number was 2.7%? Well, if you multiply that by 2, it'll only be 5.4% versus 7%. That's less. Multiply it by 1, it stays at 2.7%. So depending on what your confidence is, it's going to shrink or increase your margin of error. Does that make sense?
Yeah.
Good. Fantastic question, actually. Fantastic question. Let's go to the machines and show you the cool little, it doesn't give you a graph. Let me see if I can do this and make the camera focus on it. Great, great question, Carly. Thank you for that. Let's put this up for now. Okay. Okay. So go to your stat menu. Almost everything, and I say almost, not everything, but almost everything we do in here will be in a sub-menu we've never used before. In this case, it's called the tests menu. The tests menu. This is where almost everything we do in this class, except for a couple programs I've written for you, Liz. Now, there's a bunch of stuff in here, and it's all TIEs, which is unfortunate. So what you have to know is what the names the TI uses are. So what you have to do is you have to find the one that's talking about what we're trying to do right now. Now, what we are trying to do is we are trying to estimate a parameter. That's the whole point. Which parameter are we trying to estimate? Which parameter are we trying to estimate? That's actually part of the estimation. But what parameter are we actually trying? What was the first question last class? What is the... Think back. What was the point of giving the pennies and having me spin them? What was I trying to figure out?
Probability of heads.
The probability we get heads. So we're looking for something about a probability or a proportion. So as you look through this list, you see those props that are down there? 1 prop, 2 prop. You're looking for something with a prop in it.
So it's heads 1 or is it 2?
It's only 1, because we're looking for the percentage of heads on a coin flip. That's 1 variable. So you have to look for the one that's called 1 prop. Z is important, Alan. We have to use Z. It's this guy right here. 1 prop Z int. Now that's TIEs, and I apologize. I apologize for the TIEs. But if you put all the pieces together, it'll make sense. 1 prop means we're estimating the single probability of heads. The Z stands for the distribution we're using for those Z critical values. And what do you think int stands for? Interval, for a confidence interval. I wish it would say single prop CI, but you know, whatever, that's what I wish. So you grab that, press enter. It asks for a few values. It asks you to put in your X and your N and your C level. Because that's all we had to think about when we did our calculation. X was how many heads we got, which in this case, well, actually 160 is I think the correct number, right? Yeah, 160. N was how many times we spun, which was 340. The confidence level. Let's do Carly's again. Let's redo the 99%. You can either put in 99 or 0.99. It doesn't matter. The TI is smart enough to figure it out. So I'm just going to put in 99. When you go down to calculate and press enter, boom, there it is. You recognize our interval up there? 0.40 to 0.54, there's our 99% confidence interval. There's our 99% confidence interval. Now, I know, that's why I said don't get hung up about the whole radical P hat, Q hat, and we did it once, just like with Bert and Ernie back in 243. That's it. We don't have to do it again now. You understand how it all works together. That's all I ever want to see in classes. I want you to see how it all works. If anybody needs to see how this calculation is derived, like I said, I've got that video posted for you if you're interested in the math behind it. I'm interested more in interpreting what it means than calculating what it is. If I test you on calculating these things, I'm missing the point of statistics. That's more like an arithmetic exercise. Give you a bunch of stuff to do about. I bet you're doing your prereq quiz for 243, something just like this actually. But the important thing is knowing what it means. But first, I want to illustrate Carly's question. Remember what her question was? What happens when you mess with the confidence? Oh, go ahead, keep talking again. Keep figuring out what you're doing. Figure out what you're doing. I'm giving you props because of your question. Remember what she asked about when you change the confidence? Watch what happens. Watch what happens. Go on up here. Go back into stat tests. And go to that 1 prop Z int again. Call that bad boy up again. Leave everything the same, but change the confidence down to 95%. Change the confidence to 95%. Look what happens to your interval when you calculate it now. Notice how it changed. How did it change? How did it change? Well said, Jolene. The range got smaller. I like that. I'm going to do this. I'm going to slide this so we see our TI screen plus our little plot here. So that's at 99% confidence. That's at 99% confidence. Let's do red at 95. It goes from 42 to about 52. Let's change it again. Let's change it again. Which will you use this time? 68. 68% confidence. Love it. 68% confidence. Oh! We have achieved statistical significance between a coin flip and a coin spin, haven't we? We did it in the worst possible way, cooking the data to make a result appear. Well, we've just illustrated, thank you, Nick, for that, by the way. I know that wasn't your intent. That was not your intent, I know. We're at 44 to roughly just shy of 50%. Crap confidence. I say this partially in jest, but it's also how much crap statistics is done these days. Data are gotten, and then confidence is selected after the fact to make something appear confident. Because now you do realize that we cannot see a distinction between a coin flip and a coin spin at 99% confidence, can we? There's no statistical difference. Because 50% is in the interval, we can't distinguish between, it's a mismatch. It's like something hidden in the trees. We don't know where it is in the trees, it's just in the trees. How about at 95% confidence? Still no distinction. Still no distinction because the 50% is still hidden in the interval. But if you lower the confidence enough, you will have the 50% be outside of it. No, answer that question. Go ahead.
But can I say more often than not in the 99% that I'm landing more lower than 50%?
That's a fantastic question, and you're getting damn close to Steph's question from before about interpreting 99% confidence. Can I come back to it?
Sure.
Give me 3.5 minutes tops, and I'm probably going to answer your question too, Steph. There is something that's it's going to take you 10 weeks to figure it out to be comfortable with, and you might not even get it after 10. That's why I start you by saying how you verbally report your results. I'm 99% confident it's between 40 and 54%. I'm 95% confident it's between 42 and 52%. What Veronica just asked was a fantastic question. She said, if you look at these results right here, can't you say that since more of the interval is to the left of 0.5 than to the right of 0.5, can't you say that it's more likely that it's left than right? To which I have to ask you, is this the population or is this what? Essentially, this is indicative of what? Your sample that you drew. If we draw it again, are we going to get the same results? No, it's going to shift. So you got to be careful trying to ascertain individual probabilities from the size of these sides with a Z, of these sides with a D, of that interval, because they're going to shift too, just like our results did up here. Does that make sense? Now, Veronica's also saying, yeah, but Rule, look at your results. Almost all of them are this way, except for this goofy one right here, which tends to be out that way. I'm not saying there's not a difference. I'm saying it's not detectable in a sample of size 340. Go ahead.
But if we were to repeat this, could we say on average?
You are talking about probably the most important element of statistical inference. A result isn't worth writing about with any seriousness until it can be replicated. That's why I did that results of coin flips over time, or coin spins over time up top. If you replicate the results in exactly the same way every time and the result holds up, then you've got something to talk about. That's the idea of the intervals. They give you a look, and you might have a gut like, wait a minute, I think there might be significance hidden right here, but it's not showing up in this particular sample. So there's two things you can do. You can lower your confidence, which is a slap in the face to Carly. I refuse to accept that. Or you can keep your 99% confidence and do what?
More samples.
Do more trials, which will have the effect of doing this, won't it? Won't doing more trials have the effect of shrinking your margin of error down? That's the whole point. That's the whole point. Yeah, these margins of error shrunk down because we messed with this number out here. We made this number smaller. That's lowering confidence. That's crap. You don't do that. Especially not after the fact. You never do that after the fact because that's essentially cheating to make your data look better than it is. I think I told you this joke in 243. That's why Harrison Ford was running from the one-armed man. You remember? Yeah? That's why he was running in The Fugitive. Because somebody doctored the data. You don't do that after the fact. You look at your data and you see what your data tells you. The best thing you can do if you think there's something here is you increase this, which will have the effect of driving this whole thing down, which will have this effect as well. Is that fair enough? Is that fair enough? Good. So let me just mess with that again. Let's go back to our TIs again. Go back to our TIs again. Let's see if we can use technology to answer Veronica's question with even more specificity. Okay?